Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see how to find a first and last occurrence of an element in a sorted array. Okay, just watch out. First, we can find what is the first occurrence of the element in a sorted array. Okay, first see here. For this is array, this is a sorted array, right? Now, what is the first occurrence of that number? Let's say target is equal to 2. Okay, let's say target is equal to 2. What is the first occurrence of 2? I can say the first occurrence of 2 is here. Yes. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Then my answer should be what? 2. Answer should be 2. Understand? So this is what about the first occurrence. Okay. How can we find it? It's easy, right? It's easy. But how? Just check whether this 1 is equal to 2. No. Whether this 1 is equal to no. Whether this 2 is equal to yes. Yes. Stop here and return this 2. Fine. Now this is a linear search approach. Yes, we are checking one by one each and every elements. What is about the time complexity and space complexity? I can say time complexity is O of n, and what is the space complexity? It is O of 1 because I haven't used any extra auxiliary space. Yes, okay. Can we do it in a optimal way? In an optimal way. Okay, we got a keyword that it is what sorted. It is not sorted, so we can use what binary search. Yes. So use binary search, check for binary search. Just we can do some observations. Just see here. This is the first observation. 1, 2, 3, 4. Okay. Now I will say target is equal to 2. What is my first occurrence of 2? I will say my first occurrence of 2 is here, which is 1. So my output will be what? 1. Yes. Okay. Okay. Just assume another example. Okay. 1, 2, 3, 3, 4. Fine. Now, just assume again the target is what? 2. Just assume again the target is 2. Now, as per the binary search approach, let's go and do some stuff. Okay. Let me say this is a slower point. This is our upper point. Yes. Now, this may mid, right? This may mid because 0, 1, 2, 3, 4. 4 plus 0, 4 divided by 2, it is 2. So 2 is the midpoint. Yes. So 2 is the midpoint. Now it is 3. Whether 3 is greater than 2 or less than 2 or equal to 2, it is what? Greater than 2. Yes, greater than 2. So at this time, whether I want to move to this side or to move this side or I want to take this as my answer. These are the three cases. In most of the binary sets, we have only these three cases. Okay. The simple answer is we want to go this side. Why? Why? Because 2 will be spotted where? Towards the left side. Because it is in the ascending order here, right? So we want to move what? Left side. So if the target is less than mid value, what should I do? I should do like move towards the left side. So u is equal to mid minus 1. Yes, simple. Now again, let's take another example. Like let's take 1 and then 2, 3, 4 and target is 4. Let's say target is 4. Now what is the mid value? Mid value. Take for example. This is my mid value. Take for example. Okay. Now 2 is whether less than 4 or greater than 4 or equal to 4. It is less than 4. Yes, 2 is less than 4. Okay. So where should I move to get 4? I should move towards right side. So I can say if target is greater than the mid value. If it is a greater than the mid value, then I want to shift low to right side. Yes, low to right side. This side. This side. Okay. Okay. Fine. Now again, let's take 2, 2, 2, 2, 4. Let's take another example like this. Okay. Now 0, 1, 2, 3, 4, 5. Now, what is my midpoint? can say midpoint is 2. 5 plus 0, 5, 5 divided by 2, it is 2. So this is my midpoint. Okay. So I will take this. Whether let's take target is equal to 2. Let's take target is equal to 2. For example, now whether 2 is equal to yes, yes. So this is equal to 2. Now I will take this as my answer. This can be my answer. But still, we can take this 2. Why? Because this is the answer for the first occurrence. Yes. So we want to move towards left side. Yes. I can take this as my answer. I will say this in later. Why we will take this as my answer. Okay. I will take this. I will move towards left side. So I will move towards left side. So u is equal to mid minus 1. Yes. Now let us take again another example so that you will be clear now. Just take this as my example. Okay. Just take this as my example. Now, what is my midpoint? I can say my midpoint is what? The second index. So this is my midpoint. Now, whether midpoint is equal to the target, let's say target is equal to, yes, it is equal to the target. Now, this is my first occurrence, right? This is my first occurrence, but still we may have this kind of array. We may have this kind of array. That's why we will take the midpoint as our answer. Then we will update the upper limit towards the mid minus 1. Okay, we will go towards the left side so that we can achieve the first occurrence. Yes, now clear. You want to be clear with the first occurrence so that a slight modification we will get the last occurrence. Okay, I will say that. Just watch out. See here, I just uh, assigned array. Now target is equal to 2. So my target is 2. Low is equal to 0 and the upper limit should be set to where? Len of array minus 1. Then the first occurrence is minus 1. Then while L is less than equal to U, and then mid is equal to L plus U minus L divided by 2. Midpoint. Now if ARR of mid is equal to target, then first occurrence is equal to mid. Yes, I have told you, right? If it is equal, we want to do what? We want to set at the answer. We want to set that as an answer. Then u is equal to mid minus 1. Yes, we want to shrink the upper limit to the left side. Yes, now else if it is greater than the target, if mid value is greater than the target, then we want to shift the upper limit to the towards the left side. That's what I have told you here, right? See here, that's what I have told you here. Yes, and then if that's not a case, this target is greater than the mid value. Target is greater than the mid value. Then I want to do what? I want to shift the lower limit towards the right side. Yes, obviously. So this is what the code for the upper limit. Simple. Let me run it. Yes, we got answer as 2. Now let me make this as command. Now what will be my answer? Any guess? My answer is what? Minus 1. Because I didn't find any such value as 2, right? Yes. So my answer is what? Minus 1. Because there is no occurrence of 2. Fine. Yes. Okay. So this is what all about the what? First occurrence. Now let us see the last occurrence. It's so simple. Just see if this is the case. If this is the case, let's you see a small observation so that it will be more clear. This is the case. If this is my mid value, let me write it again. Just watch out. This is my mid value. This is my mid value. Now let's take this as 2. Now whether should I move towards left or towards right? What is your choice? I can say I will move towards right. Why? Because it may be my answer. It may be my answer, but still we will get a last occurrence. Maybe there will be a last occurrence while we are moving towards the right side. Okay, so I will move this side. So instead of this u is equal to mid minus 1, we will write L is equal to mid plus 1. That's all about the last occurrence. Okay, just see this code. It's so simple, right? See here, last occurrence I assigned as minus 1. Then that same minus h code, but still there's a slight difference called L is equal to mid plus 1 while the target and the current mid value is equal. That's all. That's all about the last occurrence. Yes. So let me run this. See here, the last occurrence is 5. Yes, this 2. This index is 5, right? Again, let me comment it and we shall run this. It will lead to the value plus -1. Why? Because there is no 2, right? So it is -1. Now, an interesting question. We already learned what are the topics? First occurrence and then last occurrence. Yes. Now, okay, we have learned this too, but where can we apply this? Where can we apply this? Okay, I will give an example. This is my array. Take this is my array. I want you to count the target value in this array. I want you to count the target value in this array. Okay. If if it is an example, I just go upon a loop like whether this one is two, no, whether this two is two, yes, yes. So I will take this as a first occurrence, and then I'll go this five, no, and then this two, yes, yes, it is equal to target. So I will take this as a last occurrence. Then these are should be the count. Yes. So this is the simple method. Now we have found out these two using what? Binary search. So what is the time complexity? It is more efficient, right? So what is the time complexity? It is more of log n. Log n to find the first occurrence and log n to find second occurrence. So it is what? 2 log n maybe. If we want to precise, it is 2 log n. And then what is space? It is log 1. So it is more efficient, right? So if we want to count, if we want to count the target element, that is in this array, we want to count the number of twos. Yes, let me write here. Yes. So this is my array, and what's the in this 0, 1, 2, 3, 4, 5. Now listen carefully. Listen carefully. What is my first occurrence? If I write the code for the first occurrence, what is my first occurrence? It is 1. 1. What's my last occurrence? Say it is what? 2. Sorry, 4. Yes. So how many twos are there? 4 twos. Yes, 4 twos. So to count a target, I can say last occurrence minus first occurrence plus 1 plus 1. If what is the case? If first occurrence is not equal to -1. If this is the case, we can do this. Okay. Until this is not a case, we cannot do this. Why? Because to find the number of count of that element, we should do what? We want that element should be in that array. Yes, if there is no element in that array, if there is no target element in that array, how can I get the how can I get the count? Yes, so this is how we want to count the target element in a sorted array. So what is the formula? Last occurrence minus first occurrence plus 1. That's all about the what? First occurrence, and how to count the elements in the sorted array. Okay, let's see the code also. See here, this is so small. Yes, see here, last occurrence minus first occurrence plus 1. That's all. So my answer is what? 4. So till now we have finished what is meant by first occurrence and what's meant by last occurrence. Let's see the real-time problem now. So we are going to solve problem number 2089. Find target indices after sorting array. Fine. So you are given a array and a target. We want to find the all indices that target present after sorting the array. Okay, that means just take this example. 1, 2, 5, 2, 3. After sorting, it will become 1, 2, 2, 3, 5. Yes. So target is 2. So where are the elements? 2. The element is at index 1 and also in index 2. So I will return 1 and 2. Fine. And then that same array, if I put target is equal to 3. See here, 3 occurred only one time and it is at the what? Third index. So I will return the third index in the array. Fine. Again, target is 5. Now 5 occurs only at the fourth index, right? So I will return array in which 4 only present. Yes. So this is my approach. Sorry, this is my question. Now We have already solved the first occurrence and then last occurrence using binary search, which is the efficient way, right? We can do also in a linear search. But what is the time complexity of linear search? The time complexity of linear search is O of n. But still, if we do a binary search approach, its time complexity is what? O of log n. Okay, fine. So, however, in this problem, we don't want to do in binary search, but still, you can see a binary search approach because in this problem, we will do a sorting operation, right? The question is what they are saying. See here, after sorting array. Yes, after sorting array. So first we want to sort that array, right? So for sorting the array, the time complexity will be what? N log n. Yes, because we can use the merge sort algorithm. But still, but still, if we use the linear search algorithm here, it is n. Whether n is greater or n log n is greater, n log n is greater. So we will take this as a time complexity. But still, we want to know about the binary search approach too, right? So we want to know about the binary search approach. So see here, just a simple thing. We can find out the first occurrence and we can find the last occurrence. The numbers that are inclusive and between this first and last occurrence are my answer, right? So it's simple. We can directly see the code. See here, see here. Just sorted the array, and then I just found out the first occurrence. Yes, and then I found out the last occurrence. Yes. Now listen carefully. If left is equal to minus 1, it means what? It means there is no such element present. Why? Because if it is if it is minus, then there is no index which is equal to the target, right? So we will just return the empty array. Fine. If that's not the case, I will include the answer as from left to right. Yes, if it is, for example, it is the first occurrence is 2. Okay, the last occurrence is 5. Let's take 2 to 5. So we want to we want to return an array which contains 2, 3, 4, 5. Right? So that's what range of left comma right plus 1. That's all. And I return the answer. Finish. So this is the real-time example for first occurrence and then last occurrence. Fine. Let me submit it. Yes, submitted successfully. So what is the time complexity for this? The time complexity of using this binary approach is O of log n, and for this sorting it is O of n log n. And what is the space? For sorting we will take the space as linear time, that is O of n. Okay, so this is what about the time complexity and space complexity. Thank you.